Okay, so today we're going to be talking about factoring special products. Factoring special products. Okay, well, when we're talking about factoring special products, we actually are talking about, because let's talk about this first. We've been actually factoring in these forms x squared plus bx plus c and ax squared plus bx plus c. We've been factoring in these two forms here. Okay, now factoring special products is no different than than factoring a regular old trinomial. It's just a shortcut that we use. Okay, that's why it's called special products. Okay, they're called special because they're special cases. Okay, these cases don't occur all the time. All right. So in this video, I'd like to accomplish recognizing special products and being able to actually factor using special product formulas that I provide for you. Okay, so let's go ahead and get started. If let's say we have a trinomial a squared plus 2ab plus b squared, and I said factor this following trinomial. Well, if I look here, I identify a as being a square number, and I identify b as being a square number, right? Because the square root of a squared is equal to a, and the square root of b squared is equal to b. Also, I can recognize something else here that, okay, what are the factors of b? We have b and b. A b squared, the factors of b squared are b and b. The factors of a squared are a and a. Well, I actually see something here. I don't know if you guys see it and know what I'm about to talk about, but I actually see something here. I see that this middle term c is actually 2 times the product of one of these factors times the product of one of the last factors. So it'll be 2 times a times b, which would be 2a, and which will be ab, which 2 times a times b, which would be 2ab. And that is equal to what I have here. Okay. So there must be something that I can say about this. There must be something that I can say about these special types of formulas here, or these special cases that I have right here. When the first number is a square, and then the last number, when your first term is a square number, and when your last term is a square number, and when your middle term is actually 2 times the product of one of the first factors times one of the factors of your last term. Okay, we can actually say something about this, but what is it that we can say? Well, let's take a look here. Let's back up here. Let's keep some space going. Okay. Now, let's say that I have this here. So we already talked about these both being, the first and the last being square numbers, and then this middle term being 2 times the product of the one of the products of your first term times the product of one of your times one of the factors of your last term. Okay. Now, this is actually, we'll call this formula 1. Okay, because there's actually 2 formulas here that I'm going to introduce to you. So formula 1. This says that if we have this trinomial here, when the first term is a square number, and the last term is a square number, and your middle term is 2 times one of the products of your first term times one of the products of your one of the factors of your last term, then it can be written in the form of a plus b times a plus b is equal to a plus b squared. It actually says that we can do this. It actually says that this would be our factor form here. Okay, well, let's look at that. If if that's true, that must mean when we FOIL this here, a plus b times a plus b, it must mean when we FOIL this, we should get this back here. Well, let's do a little proof. Let's see what the actual will give us here. So let's FOIL this. A times a will give me a squared. Then a times b, that give me plus ab. Then b times a, they give me plus ab. And then b times b, they give me plus b squared. Well, I have a squared plus 1ab plus 1ab will give me plus 2ab. and then bring down plus b squared. Well, look here. This is the same thing. This here is equivalent, is the same thing as I have up here. I wrote over there. This is the same thing that I have up here. So that must mean that this is the factored form. So that must mean that our formula here works, okay? We're going to apply this formula to actually some actual numbers here so we can actually see exactly how this works when we're dealing with numbers. And we're actually going to talk about how to recognize these square numbers just so you don't get confused. Okay. Let's say that we have another formula, which we'll call formula 2. Okay. Now let's say, what if this value was negative? What if this value was negative? What would we do at that point? Well, since it's positive now, let's go ahead and change it to negative just to see what we can experiment with. So we have a squared minus 2ab plus b squared. Well, there indeed is also a formula for this. This says it will be a minus b times a minus b, which will equal to a minus b squared. Okay? Now, these are actually your two special cases that will occur here. These are your special cases. Okay? Your special cases here. Okay? Let me rewrite this. All right, these are your special cases that will occur. All right, so let's go ahead and talk about how we can recognize these special cases, okay? Because this is a lot easier than trying to figure out what factors of b squared, what factors of b would actually give me my sum. You know, like if let's say we have this here trinomial here, using these special cases is actually a lot easier than figuring out what factors of 9 will also add to 6. You know, that's a fairly easy problem, but it's when you get into higher level problems, like let's see if we have x squared plus 16x plus 64, what factors of 64 that'll add to 16? These take a little bit more thinking here because we have to list the factors of 64. Well, we can bypass all that with our special products, okay? So let's go ahead and do this here. Let's get an example problem here. Well, first of all, let's talk about how to recognize these special products, okay? Now, we will recognize, so let's start off by a general statement. A trinomial is a perfect square, or we can say factors by special products in parentheses, because these formulas here, these are actually called perfect square trinomials. These are called perfect square trinomials. Okay? Perfect square trinomials. So we can actually say that if a trinomial is a perfect square, okay, trinomial, or factors by special products, if the first and last term are perfect squares. Are perfect squares. Okay? Also, the middle term should be 2. The middle term is 2 times 1 factor of the first term and 1 factor of the last term. Okay? And you'll, in a minute here in this video, if you don't understand what I mean by that, of course you'll see it when I do my examples. Okay? Alright, so this here says a trinomial is a perfect square or factors by special products if the first and last term are perfect squares. So like we have a is a perfect square because the square root of a squared, a squared is a perfect square because the square root of a squared will give me a. And then the last term is a perfect square, so the square root of b squared will be b, right? And then it also says here the middle term, which is this here, should be 2 times one of the factors of the first term and then one of the factor of the last term. Okay, so let's actually see how all of this will look here. Okay, let's see how this will look. Well, let's get an example problem. Let's pick orange here. So we have, let's say we have x squared plus 6x plus 9, right? Well, x squared plus 6x plus 9, well, first of all, let's check. Is the trinomial, okay, if it factors by my special products, that means the first and the last term are perfect squares, okay? Perfect squares. Well, let's look for that. Is it a perfect square? Well, my first term, that's a perfect square because the square root of x will be equal to x. And then my last term, 9, the square root of 9 is equal to 3, so that's a perfect square. Perfect, so I'm almost halfway done. But in order for it to be a perfect square, in order for it to be a square, perfect square trinomial, the middle term should be 2 times one of the factors of the first term and one factor of the last term. Okay? Well, let's take a look at that here. If we look at, okay, so 2 times one of the factors of the first term, well, what's one of the factors of x squared are x and x, so we'll take 1x, and so this is the product of x and one of the factors of our last term. Well, the square root of 9, the factors of 9 are 3 and 3, so let's take 3. So it'll be 2 times x times 3, right? Which will be equal to 2 times x times 3 is 3x. So then I'm doing 2 times 3x, which will give me 6x. And isn't that what I have as my middle term? Yes, it is. So that must mean what? That must mean that this is indeed a perfect square trinomial. Okay, a perfect square trinomial. So that means it'll factor by special cases. Okay, well, let's go ahead and actually factor this thing by special cases here. Let's go ahead and factor it by the special case. So that was x squared plus 6x plus 9. So let's go ahead and factor that up by the special cases. Well, what does our formula say here? Since it's all positives, that means we're going to use our positive formula here, which says when we have, it says we'll have a plus b times a plus b. Well, let's look here. What's our a in this case? Our a would be our x, right? Because we take the square root of it, okay? Plus our b. What is the square root of 9? 3. And it said times a plus b again. Okay, so you're doing x plus 3 times x plus 3 because we'll say that that's a, we'll say that that's b. The square root of these numbers would give me our a and our b, right? Okay. Now, x plus 3 times x plus 3 is the same thing as x plus 3 squared, which is indeed my factored form of, or you can write it like this here. This is my factored form of x squared plus 6x plus 9. Now, let's go ahead and check it here. Let's go ahead and do a little check. Okay. Well, if x plus 3 times x plus 3 is indeed the factors of this, that means if we FOIL this, we'll get this back. Well, we do x times x, that'll give us x squared, plus 3x times 3, that'll give me 3x, plus these two, your inner terms, that'll be 3x, and then your last terms, that'll give you plus 9. So this will be x squared plus 6x plus 9, which is equivalent to this here. So that must mean that this is the factors. This is the factored form of this here. Okay? So that must mean that's the factored form. All right, so we're going to stop this video here, and we're actually going to resume in the next video with more example problems.